Well, I hope you're happy. I did all of this work, talked through all of this stuff, and I forgot to hit record. All right, let's get started, I guess, again. Welcome to finding the least common multiple and greatest common factor of a set of numbers or values. Excuse the blooper. Started talking, realized I said something backwards. Gonna try it again. The key difference between least common multiple and greatest common factor is that least common multiple is the smallest number or value which can be multiplied from a set of numbers or values, and GCF, greatest common factor, which is the largest number that can be divided from a set of numbers or values. That is going to lead to the key difference being that GCF is going to be equal to or less than the original numbers versus LCM, which will be equal to or more than the original numbers. The reason that GCF can be equal to or less is that with division, if you divide by 1, a number might not actually change. But if you divide by any whole number other than 1, your answer will end up becoming smaller and less. Versus for multiplication, again, excluding multiplying by 1, your answer is always going to be larger, assuming you are using whole and positive values. The methods behind finding them can be broken down into a couple of camps. For LCM, there are two very reliable methods that tend to work. GCF does have 3 methods. I'm going to talk about all 3 of them, but there are only 2 that I would advise actually using for GCF. So I'm not entirely sure if you could tell through the fast forward, but this process, while effective, can be a little bit slow, especially when you are dealing with numbers like 12 and 7. Since 12 and 7 do not share any factors, the multiple is going to end up being what 7 times 12 was. This is not always the case, but it's good to keep note of for future reference. Let me give you another example, this time without the fast forward so you can see what is happening. We're going to find, for this next problem, we're going to work on finding the LCM of, we will say, 6 and 8 as an example. 6 and 8 do share some common factors, so our answer is going to be a little bit closer than when we did 12 and 7. Starting off with 6, I'm just going to list a few multiples at a time. I'm going to start by going 6, 12, 18, and then I'm going to pause for a moment. I'm going to switch over to the multiples of 8. 8, 16, 24, and I don't quite have a match yet, so I'm going to go a little bit farther. 32, 40, and let's see if 6 has made any progress. We were at 18, keep going with the 6s, 6, 12, 18, 24, and then I'm actually going to stop. I'm stopping because I have found my match, earlier than possibly I would have expected. My match happened right here at 24. So I can safely say that my LCM is 24. My LCM is not going to be 48, which is what I would have gotten if I did 6 times 8. 6 times 8 in this case is going to be a common multiple, but it is not going to be the least common multiple. It is not the smallest possible number that could have been multiplied by 6 or by 8. Now, on to method 2. So, method 2, Tic Tac Toe, as you can see, has a few steps, but I assure you that once you get used to doing them, they become second nature. The other fun thing about Tic Tac Toe is it can be used for both least common multiple and GCF, and will also be incredibly useful when we start rewriting expressions using distributive property, which is also a part of our current unit. And it can also be used to help simplify fractions and ratios, but that's a topic for another unit. To start, set up a Tic Tac Toe and place originals in top middle and top right boxes. For ease of use, we're going to use 12 and 7 for this problem, the same as before, so that we make sure we know what answers we're going to get. I set up my Tic Tac Toe board, and I'm going to put my originals at the top, 12 and 7. Step 2, I'm going to place any common factor I can think of in the top left. Lucky for us, 12 and 7 do not share any common factors, other than, of course, 1. It then says to divide the originals by that factor and place answers below. Not really necessary for this. If you really wanted to, you could go ahead and put 12 and 7 and another 1, but that's just a waste of time. Repeat as necessary refers to this 1. Whenever you get to the end of your division, you'll know this because all you will have left is the number 1. So, with the number 1 being there, I know that I need to multiply everything inside of the L. The L usually will go further down than this, but since it's at the top, we're going to multiply everything that finds itself in this area. 1 times 12 times 7. That way we don't really have to sit down and list all of these multiples. We will know straight away that all we really had to do was 12 times 7, which we already know the answer, 84. The next one we're going to do is not going to be 8 and 6. I would rather do this with a slightly larger number. Instead, we'll give it a shot with, say, 12 and 8. Eight here, 12 here. Once again, we're going to place any common factor in the far left. Since these happen to be even numbers, we're going to divide by 2. After we choose that number, we're going to divide the originals by that factor. 8 divided by 2 will give me 4, and that will go here. 12 divided by 2 is going to give me 6, and place that here. I take a look and I see that both 4 and 6 can be divided again. So I'm going to repeat. 6 and 4 can both be divided by 2 since they are even numbers. 4 divided by 2 gives me 2 again. And 6 divided by 2 gives me 3. Now that I've reached here, I can't go any farther. Not because I've run out of room, I can always just draw more lines and keep going. There's no rules against doing that. But that's not going to be necessary since 2 and 3 do not have any more common factors. At this point, I'm going to take everything inside of an L shape. Going to go all the way down and all the way to the side. It wouldn't have been right if I did 8 times 12 for this. Instead, I have to do 2 times 2 times 1 times 2 times 3. So, 2 times 2 gives me 4, times 1 is still 4, times 2, so that 4 times 2 is going to give me 8, and that 8 times 3 gives me an LCM of 24. Those are the 2 prime methods that I'm going to suggest for finding least common multiple. Now on to GCF, or greatest common factor. Method number 1 for finding greatest common factor is going to be using prime factorization. Step 1, use prime factorization. Duh. Step 2, multiply common factors together. That sounds a little strange, so I'll show you what I mean. We're going to use 24 and 18 as my examples. 24 can be broken down with a 2 and a 12. That 12 can be broken down into a 3 and a 4, and that 4 can be broken down into two 2s. That 18 can be broken down into a 3 and a 6. That 6 can be broken down into a 2 and a 3. Now, for the fun part, combining my common factors. I can see that I have two 3s on this side, but I only have one 3 on this side, meaning my common factors include a single 3, and I can see I only really have a 2, one of each on each side. So the only common factors I have is 1 2 and 1 3. In order to find my GCF, I'm going to take those two common parts, a 2 and a 3, and I'm going to multiply them. 2 times 3 gives me a GCF of 6. That's how to use prime factorization. But there are two more methods. The second method, while a little bit more popular, has a few more flaws. Like I said, this method might be more popular, but it's considerably more flawed. List factors, choose the largest one in common. That is all. The example we're going to use here, once again, will be 24 and 18. And I'll show you why I find this method to be a little bit flawed. If I set up 24 here, and I set up 18 here, I have to list everything that I can possibly think of to divide both 24 and 18. Simple enough, right? Unless you don't know your multiplication facts as well. Let's say I get started, and I start off by knowing, okay, 24, I can divide that by 1 and get 24. That's pretty obvious. I can do 2, divide by 2 to get 12. I can do 24, divide by 3 to get 8. Can't really think of anything else. I'm going to move on to the next one. Then you go down to 18, and once again you do, okay, 1 and 18. I know that. I know 2 and 18 would give me 9. So 18 divided by 2 gives me 9. And I know 18 divided by 3 gives me 6. And that's all I can think of. If I don't know my times tables all that well, I could be mistaken, and I might think, oh, okay, my greatest common factor between these two is going to be 3 because that's the biggest one they have in common. That's a problem. The only reason I might come to that conclusion is because I would have forgot that 24 can be divided by 4 to give me 6. Which means that now my real greatest common factor is going to be that 6. That's the issue with the old school method. I'm not saying that it doesn't work, just that it has a couple of flaws. If you are strong with your multiplication facts, this is a very good way to do it. If you're not so strong on your multiplication facts, this might be a method you want to stay away from. But there's one more, and like I kind of hinted before, it's going to be the return of Tic Tac Toe. For Tic Tac Toe, it's honestly going to be those same exact directions. Set up Tic Tac Toe, place any common factor on the left, divide the originals by that factor, place answers below, repeat as necessary. The one step that's going to be different is that you are only going to multiply the values on the far left side. You're not going to do the entire L shape. Let me show you what I mean using once again that 24 and 18. I set up my Tic Tac Toe with a 24 and 18. I know that I can divide both 24 and 18 by 2. They are even numbers after all. I will take 24 divided by 2 to get 12, and 18 divided by 2 to get 9. At this point, I recognize that 12 and 9 can both be divided by 3, which will give me my answers of 4 and 3. And at that point, 4 and 3, they cannot be divided anymore. So I'm going to finish it off by putting a 1, just to make sure that I remember that I'm finished with this problem. In order to find GCF instead of LCM, I'm only going to multiply what is in that far left column. Sometimes, to help people remember, I like to draw the letter G around that column, just to help remind them that the L is for LCM and the G is for GCF. Once you've got this, you just multiply. 2 times 3, that gives me 6, times 1, and that's still 6. My GCF is going to be 6. That's just one example. Another example I can give you is what would happen if you need to add more lines. And if that happens, it can still work. We'll try 36 and 48. I intentionally left it longer because I plan to have us go on longer for this one. 36 and 48, those can both be divided by 2, which is going to give me a result of 18 and 24. Once I have 18 and 24, I can divide those by, I'm going to say 2 again, which is going to give me an answer of 9 and 12. But unlike before, I know that I can actually keep going. 9 and 12 are both a member of the 3 times tables, so I'm going to just draw an extra bar and continue moving. I can divide both of those numbers by 3, not 2. 9 divided by 3 gives me 3, and 12 divided by 3 gives me 4. Once I have that 1 there, I know that I'm finished. I can now multiply 2 times 2 to give me 4 times 3, which gives me 12, and times 1, which keeps it at 12. And that's it. Here are the complete notes for least common multiple and greatest common factor. I hope you guys appreciate it. I hope you guys got what you needed out of this little video. I actually made some improvements from the old one, so yeah, I think that went rather well. Hopefully I don't have to record this again. Not that I don't mind doing the extra work for you guys, but it's a bit of a pain when I've already recorded this once. Crossing my fingers this recorded. See you next time.